It started quietly. No grand announcement, no countdown, no headline-grabbing discovery. Just another Martian night and Perseverance doing what it always does, scanning the sky above Jezero crater with its navigation cameras. But on October 4th, 2025, something unusual appeared in one of those frames. A thin, glowing streak slicing across the cold red sky. The camera wasn't even meant to capture the stars. It's built to help the rover drive, dodge rocks, and plan routes. Yet there it was, a faint trail of light that didn't belong. When NASA's imaging team reviewed the data, they realized what they were looking at, the interstellar comet 3I/Atlas, caught passing near Mars almost by chance. The image soon went viral, a moment of pure cosmic luck, and it's now featured as NASA's Image of the Week. It was the unmistakable trace of 3I/Atlas, the interstellar comet that had been the subject of global fascination for months, passing just 0.19 AU from Mars. The image looks almost too perfect, a symmetrical, luminous line, as if engineered, and that has stirred excitement, curiosity, and, inevitably, controversy. Here's the catch. Perseverance's navcam isn't made to look deep into space. Its job is to spot rocks, dust, and terrain hazards nearby. So when it tries to image something as far away as 3I/Atlas, nearly 38 million kilometers from Mars, the scale becomes enormous. Each pixel in that photo represents around 12,000 kilometers of space. In the image, the bright stripe appears roughly 4 times longer than it is wide. Crunch the numbers, and suddenly, it looks like a 50,000 kilometer long structure, far too massive to be real. That's where things start to unravel. According to previous measurements from NASA's SPH-REX mission, the actual size of 3I/Atlas is capped at around 46 kilometers, assuming it reflects just 4% of the sunlight hitting it. That's 1,000 times smaller than what the navcam image seems to show. So, either the comet is something we've never seen before, or the image is playing tricks on us. If 3I/Atlas really were a colossal 50,000 kilometer cylinder, the Hubble Space Telescope would have captured it easily back in July 2025. Instead, Hubble saw it as a tiny, unresolved dot, a mere speck against the cosmic backdrop. So the question naturally follows, what did Perseverance actually photograph? The most likely answer, motion blur. Or, as one scientist joked, emotion blur, given the excitement it sparked. To detect something as faint as 3I/Atlas from Mars's surface, Perseverance's imaging team had to stack hundreds of short exposures over several minutes. During that time, the comet moved noticeably against the background stars. The result? A stretched-out trail that looked more like a craft than a comet. Still, the image took the internet by storm. Space enthusiasts flooded social media with theories, from interstellar visitors to alien probes. The best processed version of the image, credited to an independent astronomy account on Twitter, link in the description, shows a refined version of the streak that highlights its movement and brightness profile. Meanwhile, orbiters around Mars were watching the same sky that night. The Mars Reconnaissance Orbiter, MAVEN, and ExoMars TGO all turned their instruments toward the faint trail of 3I/Atlas. For a few surreal hours, Mars became the first planet besides Earth to simultaneously observe an interstellar visitor from both orbit and surface, a historic first in planetary science. And now, the real test begins. The image that may finally settle the debate about 3I/Atlas's true size and structure is coming soon. From HiRISE, the ultra-powerful camera aboard the Mars Reconnaissance Orbiter. Its observation on October 3rd captured data at 30 kilometers per pixel, over 400 times sharper than Perseverance's navcam. When that data drops, we may finally separate myth from reality and find out what really streaked across the Martian sky that night. Ironically, Just as the cosmos was putting on its most thrilling show, many NASA websites and feeds went silent, caught up in a government shutdown at the worst possible time. Researchers across the globe were eager to track what could be the most unusual visitor to ever pass through our solar system, yet public access vanished almost overnight. The timing felt uncanny, and speculation ran wild.
Some whispered it might be a highly active comet unlike anything seen before. Others ventured wilder ideas: a probe from beyond the stars, alien technology, even a spacecraft of unknown origin. Whether any of that is likely or not, the blackout only fueled curiosity. But hope remained. On October 2nd, Perseverance captured a streak across a sequence of multi-minute exposures, and scientists sprang into action. Unlike typical star trails caused by Mars's rotation, this streak was slanted and consistent across frames. It wasn't a glitch, a cosmic trick, or a camera error. It was real. It was 3I by Atlas itself. Credit goes to Drew, a sharp-eyed observer on Twitter, whose post sparked a wave of analysis that confirmed the streak's authenticity. The comet's size remains uncertain, though estimates suggest a nucleus at least 5 kilometers wide. Unlike classic comets, it lacks a dramatic, sweeping dust tail. Instead, it seems cloaked in a diffuse, ionized coma, shimmering around it like a ghostly veil. Its speed is staggering, roughly 60 kilometers per second, accelerating towards 68 kilometers per second near perihelion at the end of October. Even a coronal mass ejection that hit the comet around September 25th left little dramatic mark. Follow-up images on September 27th and October 2nd showed no catastrophic fragmentation or tail breakoff, only a subtle expansion of its gaseous envelope. The lack of immediate drama is why the NASA blackout was so frustrating for those eager to witness it in real time. Fortunately, humanity wasn't completely blind. ESA's Mars Express and ExoMars Trace Gas Orbiter also trained on 3I by Atlas during its flyby, collecting images, spectra, and measurements of its coma and tail dynamics. The upcoming JUICE mission will further intercept and monitor the comet as it moves toward perihelion. Even with communication delays, these assets together promise a detailed portrait of 3I by Atlas. For now, the mysterious streak captured by Perseverance is not an alien artifact, nor is it anywhere near the massive scales some sensational reports suggested. It's a cosmic visitor moving fast, strange, and beautiful. And for scientists, it's a reminder that the universe still holds surprises, even when government websites go dark. So, just how big is 3I by Atlas? Measuring a comet's true size is trickier than it seems. The problem is separating the solid nucleus from the hazy, glowing coma that surrounds it. As a comet nears the sun, frozen ices vaporize, carrying dust along and creating the dramatic tails and envelopes that make these objects appear far larger and brighter than their actual cores. A team from Harvard, led by Richard Kluda, Avi Loeb, and Peter Varesh, tackled this challenge using data collected from 227 observatories worldwide between May 15th and September 23rd, shared through the Minor Planet Center. They compared the comet's actual trajectory to what physics predicts if only gravity were acting on it. They found a small but measurable push, less than 15 meters per day. Normally, comets get slight boosts from jets of escaping gas, but 3I by Atlas's outgassing seemed too weak to produce much acceleration. That implies the nucleus is heavier than expected, resisting the push of its own vaporized gases. From these calculations, the team estimates a core mass over 33 billion tons, with a diameter around 5 kilometers, excluding the surrounding coma. This makes it thousands of times more massive than earlier interstellar visitors. Avi Loeb points out something curious. If interstellar space follows the expected population of small bodies, we should have spotted many smaller interstellar objects by now. Yet we haven't. The size and mass of 3I by Atlas make it a remarkable outlier. Loeb even entertains the provocative idea that its origin could be technological, citing its large mass, precise trajectory, and unusual chemical hints like nickel without iron. NASA scientists, however, caution against jumping to exotic conclusions. Their analysis shows 3I by Atlas is active, producing a visible coma, which aligns with it being a natural comet. The observations confirm it's not just a mysterious speck in the sky. It's a massive, fast-moving traveler from beyond our solar system, quietly rewriting what we know about interstellar objects. Some scientists aren't just asking what 3I by Atlas is, but what it could do. Astrophysicist Suzanne Falsner offers a bold idea. This interstellar traveler could be a planet-making seed. At first, it sounds almost fantastical. How could a lone rock from another star system spark the birth of a planet? But the more you explore it, the more intriguing the possibility becomes. Picture a young solar system, a newborn sun surrounded by a swirling dusty disk. Tiny grains collide and stick together, gradually forming pebbles, then boulders, and eventually planetesimals, the building blocks of planets. Over millions of years, these clumps grow massive enough to capture gas and dust, slowly forming full-fledged planets. Simple in theory, but there's a catch. The gas in these disks only lasts a few million years, often not enough time to create massive gas giants like Jupiter or Saturn from scratch.
Now imagine a twist. An interstellar object like 3I Oasis Atlas plunges into this disk. Suddenly, the system isn't starting from scratch. It has a ready-made solid core, a seed around which gas and dust can quickly gather. This cosmic shortcut could accelerate planet formation dramatically. Falsner's simulations show that massive stars are particularly good at capturing such visitors, which might explain why gas giants are more common around bigger stars, a tantalizing alignment between theory and observation. If this is right, then interstellar objects like Oasis Atlas, Borisov, and 3I Oasis Atlas aren't just drifting curiosities. They may be catalysts, nudging the birth of planets in distant systems. Some might even have played a role in shaping our own solar system billions of years ago. It's a daring hypothesis, still unproven, but it forces us to rethink these cosmic wanderers not as mere travelers, but as agents of creation. The challenge, of course, is that interstellar objects are elusive. They appear suddenly, move at breakneck speed, and vanish into the darkness before most instruments can track them. This time, however, astronomers are ahead of the curve. With early detection and modern observational technology, we may finally uncover what 3I Oasis Atlas truly is, and maybe, just maybe, glimpse the role such objects play in the grand story of planetary birth.